Growth and decay is a lot like compound interest. I don't know if that's true or not, but I'm going to say it. Growth and decay. And what you have to think about is, think about this, like a sequence. Growth and decay. First of all, if you have a sequence that's this 6, 12, 18, 24, what would be the next couple things there? You know it's obviously going to be what? Somebody 30,
36,
36, blah, blah, blah. What is, you know, what are you doing between each term?
multiplying.
You're just adding. You're adding 6. Okay. This is not growth and decay. So I have to give you the not before I do the thing. This is growth and decay. Let's do a growth one. Okay. 2, 4, 8, 16, 32, 64, and you know the next thing would be 128. And what the deal with that is, the common, what you do between terms is, in this case, you're doing what?
Multiplying.
Yeah, you are multiplying. You are doubling, actually, every time. Okay, this is what we call growth. You know, it's like bacteria. Mrs. Stone talked about bacteria growth. It starts with this one little thing, and then it starts getting out of control. If you're graphing growth, you know, it starts small and gets bigger, smaller, smaller, and then it really gets out of control and gets big really fast. Okay, that is growth. Decay is kind of the same thing. And decay, you'll hear about, you know, when people talk about carbon dating things, which doesn't work. You know, you start with a big thing. You know, let's say you start with 64, and then you get 32, and then you get 16, and then you get 8, and then you get 4, and then you get, what, 2. What would you get after that?
1.
1, and then what would you get?
0.5.
0.5, or half, and then you get
0.25.
1/4, and then you get
1/8.
1/8, and blah, blah, blah. What is the common factor between this?
Divide by 2.
Divide by 2,
1/2.
or
Multiply by 1/2.
multiply by 1/2. And you multiply by 1/2. And what does that look like if you're graphing it? Well, what it looks like is this. You start really high, and then you go really fast to the little thing. Okay, but you will never ever get this 0 part right there. Here's what you need to think about when you do that, because they will ask you this. Find the next term in this growth sequence. Find the next term in this growth thing. And here it is. This is kind of confusing because we have a hard time when it comes to this. 16, 24, 36, 54. What would be the next thing there? Well, here's what confuses people. Well, to go from this to this, you get what?
8.
You know, you would add 8. But to go from this to this, you
Add 12.
add 12. And then to go from this to this, you add 18. How does that work? How do you know what's going on there? Now, what I would challenge you is this. This is not an adding between terms. You have to figure out what the common factor is. And this is all you have to do. Check and see how easy this is. You are just asking yourself, 16 times what number gives you 24? 16 times what gives you 24? And by the beauty of solving equations, you do this, divide by 16, divide by 16, reduce that, you get, divide these both by 8, 3/2. So that's all you have to do between each term. Multiply by 3/2, multiply by 3/2, multiply by 3/2. If I take 54 and multiply it by 3/2, or you can multiply by 1.5, it's up to you, whatever it is there. 2 goes into that 27 times. The next term would be 81. And then you get the next one after that. You'd multiply by 3/2. And then unfortunately, you get 243 over 2 or something like that. You get some decimals or something like that. Or another one, you say. Can we do another one?
Another one.
Yeah, let's do another one.
What if it was this? And this is right out of the book. 256, and then 192, and then 144, and 108. What would be the next term? Who knows? But the way to figure it out is, again, once you realize that this is not done by plussing or minusing, you could just pick any two terms and do the same thing we just did. Let's pick these two. What times 144 will give me 108? I'll divide by 144, divide by 144, reduce this. What do we get? Half of this is 54 over 72, 27 over 36, 9 goes into those 3/4. Multiply by 0.75 or 3/4 and you will get the next number. 108 times 3/4. 4 goes into this what? 27 times. Oh look, it's 81. The same thing. Multiply 81 by 3/4 or 0.75. You'll get the answer. And blah 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 blah. So, look in your books on 683. Let's see if we can't make heads or tails about this. Look at practice letter C. This gets a little confusing, so I hope I can do it. Is that a soccer ball in your shirt? Yeah, I didn't know you played soccer. Oh, why are you wearing that then?
Oh, my mom got it. I found it in my closet. That was at like 7:30 this morning.
So really, you only woke up an hour and a half ago? Oh. Letter C, look at it, top of page 683, ladies and gentlemen. The schools in an older community experienced a decline, which would be decay, in the student population of 3% per year. If the decline continues at the same rate, and there are 5,000 students in the community this year, about how many students will be in the community in 3 years? Ooh, that's going to be ugly. But how would that work? So you're looking for this. Boom, 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 boom. Okay, this year is 5,000, right? So then you've got the next year, after 1 year, after 2 years, after 3 years. They want to know blank, 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 what this one will be. Now the question you have to ask yourself is, it's a decline. Well, how do I, it's a 3% decline, so what would I do to this to get a 3% decline? Now you can take 3%, subtract it, which is one way to do it. Well sure, should we do it? Let's do it that way. What's 3% of 5,000? 5,000 times 0.03. To me, it looks like it's 150. Does that sound right? Should we just go with that? Can I go with that?
Sure.
So what? How many students do I have now? 4,850. Then I could take. I have to then take 4,850 and multiply that. Sorry, by 3%. Boy, it'd be nice to have a calculator here, wouldn't it? 0, 15, 24, 25, 2, 3 times. This time I'm going to decline how many students? 145, 146. Let's go 145. So what is 4850 times minus 145? 517. 4,715. Then I'd have to multiply that by 3%. Is there a faster way to do that than multiplying by 3% and subtracting? Anybody? How about this?
It's 470.
If it's a decline of 3%, what percent stays? 97%. So it's the same thing. Declining by 3% is the same thing as staying by 97%. So you could take 4715 and multiply it by 0.97. Whatever you get is what your answer that goes there. Ooh, that's going to be ugly.
4705.
Would you stop? Wow, that was, I don't know what that was called for. 28 what? It's 28 and 45, 4, 13, 1, 63, 64, 6, 36, 42, 5, 5, 3, 7, 5, 4. Is that what you said?
It's the nearest 100. That's why I did.
Wait, to the nearest 100?
Yeah.
100?
100.
100? So 4,600. Can I see what my book has for an answer for that? 4,600 is what it has for the answer to that one, yes. Or look at letter D. The number of bacteria in a culture increased from about 2,000 to 4,000 in 1 hour. Assuming bacteria population grows exponentially, which is what we are doing, by the way. Exponential growth is when you multiply by factors. Doubling things is exponential growth. How much longer will it take the number to increase to 16,000? Now, let's put this together. Let's think about this mathematically, people, because not always is everything just, as students, you just want one simple little easy answer to it. You don't want to do any work, right, Brand? You just want to coast along and do absolutely nothing and try to get 100% on everything, right, just without doing any work. That's kind of where we go. What would be the best way to do this is to kind of map it out. Draw a little chart. What happens in this little chart? Well, what's it tell you? It starts out at what? 2,000, right? Just work with me here. It goes from 2,000 to 4,000 in an hour. So it goes from 2,000 to 4,000 in 1 hour. Okay, this is the first hour. The second hour, what's going to happen? It's going to double again. It goes to 8,000. The third hour, 16,000. What's the question to ask you?
How many hours does it take to get 16,000?
How many hours will it take to get to 16,000?
How much longer?
How much longer does it take to go from there to 16,000? How many hours is it from here to here? 2 hours. It's 3 hours from the start, but only 2 hours from after the first hour. 2 hours. This, I guess, I should have been after the first hour, second hour, third hour. In the fourth hour, it'd be 32,000. And again, if God was not in control, why would bacteria take over the world? Because they do. What's stopping bacteria from
Clorox.
Yeah, but not everybody has the ability to get Clorox. Who has a chance to get Clorox?
Our immune system.
Where did Clorox come before? There was people who made Clorox bottles. All right, for tomorrow.